which sets PA4 high, delays the MPU exactly half a second with a 2097152 Hz external oscillator, and sets PA low, delays another half a second, and repeats using only instruction delays. Use subroutines. Okay, now let's go ahead and see how to do this. First, this is what we have provided, that is external value, external oscillator, that is 2,097,152 Hz. Let's note this one down. External is equal to 209,715 Hz, and in order to find out the clock cycles per second, we have to find out the internal clock, which is E clock. Okay, that one can be calculated by dividing external by 4, because the relationship between external and the internal clock is equivalent to external divided by 4. E clock is equal to external divided by 4, and then external is this value, that is 209,715,7152. Divide this one by 4, and that gives the number of cycles per second, that is 524,288 cycles per second. But in the question, we are doing it for the half a second, so we have to divide this one by 2 again, that is 262144, and this is cycles per half second. Okay, now based on this, now we have to derive this many cycles. Okay, this is what we need to achieve. We are gonna write a code to achieve this one. Okay, now let's go ahead and do that in the next page. And in order to do this one, first you have to know one thing, that this is mentioned that this set the PA4 high, and also set the PA4 low. And if you look at port A has the range of PA7 to PA0, and from the PA given, we have to calculate what we need to load here. So the one we need to load is PA4 high. To calculate what we need to do, we just put the PA number, in this case that is 4, so we put a 4, 2 power 4, that is 16. So we have to load the 16 in the coding. Okay, let's go ahead and start the coding. The coding, we start with start, and then load the PA4 high, LDAA, and to load the PA4 high, we load 16, and you can either load it in hexadecimal or binary. If you load it in hexadecimal, that is just 10. If you load it in binary, then you have to put this $sign represents hexadecimal, and then if you want to represent in binary, you put a percentage sign, that's binary. And hexadecimal, each digit represents 4 bits, so 2 digits is enough to represent 8 bits. But in binary, you need to write 8 digits to represent 8 bits, and also 16 is basically 0001, and then rest of them are 8 digits. Okay, you can write this one or this one, both of them works. And then after that, we had to store whatever we load in the port A. Store accumulator A, port A. And then we are using subroutine here, so first subroutine JSR, and we are gonna jump to subroutine, that is delay. We are gonna create this one later. And we loaded PA4 high, and now if we have to load the PA4 low, that is 0. So it doesn't matter what PA you have, you may have PA5, PA6, whatever, the low is going to be always 0. The high is decided based on the number. If it's PA5, you put 2 power 5 and stuff like that. So here this is LDAA, and then we load 0, and then STA store in the accumulator array, port A, and JSR jump to subroutine delay, and BRA, that is branch always to start. Okay, so and I have to keep on counting on the bottom. I don't have space, so I'm going to do it over here. Let's separate this. Okay, this one continues over here, and after that, now we are gonna create the subroutine. It jumps to, that is delay, and we use this one to load the index X register with a certain value. So delay, and in this one I'm gonna put LDX, and here I have to load a value that should be like, we have to decide this one based on, this is what we are trying to achieve. We need to derive this many cycles, so we have to calculate all the cycles we are using and how many rest we require. Then we use this one to fill it up. So this one was necessary to run the loop. Here I'm going to create the loop, delay loop, and to keep the loop running, I do the decrement of X, dx, and then we have to keep on looping. So BNE, so this X value, whatever the loading value, is going to be decremented by 1 each time, and every time if it's not 0, it's going to keep on branching back. This is branch not equal to 0. If you keep on branching back to this, so to branch to this one, I mention the name here. Where should it branch to? That is delay loop. And after that, I leave some space, because in case we calculated and we need some extra 2 or 3 cycles. Let's look at that. So if you need extra 2 or 3 cycles, you can use either nope, that takes 2 cycles, or you can use BRN, that's branch never, and with the asterisk, that takes 3 cycles. You can choose either of them based on your needs. So let's see if we even need them, but currently we just put all the things necessary. So this is return from subroutine RTS, that's at the end. If you are using subroutines, we have to do this at the end. And then let's look at the cycle required. Loading into accumulator array, storing accumulator array, both of them take 4 cycles. I use the comment to explain that. 4 cycles. Let me use a different color. 4 cycles. And storing also requires just 4 cycles. Loading and storing 4 cycles. And if you look at the subroutine, most of them just 5 cycles. So this is 5, and this subroutine, jump to subroutine 5, and return from subroutine, that's also 5. Okay, and branch always, that doesn't require any cycle, and this one load X requires 3 cycles, and decrement of X requires 3 cycles, BNE requires 3 cycles. So if you calculate this one, 4 plus 4 plus 5, that is 8 plus 5, that is 13. 13 times 2, that is 26. We have 26 here, and then this 329, and then this 5, that is 34. So totally we have 34 cycles, and I don't include this one because this is a loop. This is gonna repeat whatever based on whatever number we put here. For example, if I put 1000, this is gonna repeat 1000 times, then we are gonna have 6000 cycles. So that's why I didn't include this one, because we had to calculate how many we need to put in order to accomplish this. So to accomplish that, so I calculate all of them that just occurs once. This occurs once, occurs once, occurs once, occurs once, and all of them together just 34. And I grab this number 262 144, 262 144, and I subtract the one that occurs once, that's 34, and that's gonna give me 262 110. And then I divide this by 6 because each cycle, each loop, each time it runs a loop, it takes 6 cycles. So I divide them by 6 and see if I am getting a whole number. If I get a whole number, I'm good. If I don't get the whole number, then only I use one of these to adjust to get the whole number. So currently I have this one. Let's divide this by 6 and see if I am getting a whole number. So I use a calculator. 262 110 divided by 6. I'm getting a whole number right away, so I don't need anything, any of these instructions, because this is not necessary at all. So 43685, this is what I'm getting if I divide this. So I put that one for the x value, the loading value, 43685, and we had to put this as this sign to represent this a decimal number. If you don't put this is gonna point to address, and that's gonna be completely different story. So in order to express this is a decimal value, we put the ampersand sign, like this number sign. Okay, so now we have this, and if you calculate this one, you should get this one back. So we already calculated the one that just occurs once, so that is 34 plus, and then 6, that is these two. That one happened this many times, 43685, and if you calculate this one, you should get this one back. Okay, let's go ahead and put it in the calculator and see if I'm getting it. So I do the big one first. 6 times 43685, that gave me 262,110, and I am adding 34 to it. That gave me 262,144. Is that the one we have? Yes. So that means it is done perfectly. And that's it for this video. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.